Hello. In this video, we'll go through an example showing how to use the SoftHub configuration utility to create the objects needed to configure the SoftHub to connect to multiple sensors and to publish each sensor's data to a remote MQTT broker. As in our previous video, we'll then deploy the configuration file and restart the SoftHub daemon, which will then connect to our chosen sensors and begin publishing the sensor data to our target MQTT broker. Instead of publishing our packets to a dashboard as we did in the previous video, in this video we'll use the MQTT.fx utility to subscribe to the topic we'll publish to so that we can see the actual JSON packet data that the SoftHub generates. We've put a link in the video description to the MQTT.fx website where you can download a copy of the utility we've used. For the demonstration, we're again running the SoftHub daemon on a Raspberry Pi Zero, and we'll connect to 3 sensors. This time we'll be connecting to a Bluetooth Senserion SmatGadget, a Bluetooth Nordic Thingy 52, and an ANT Garmin Tempe sensor. Here we've opened the SoftHub configuration utility. We'll create a new configuration file and then create the few objects and rule set we'll need to implement our example scenario. We'll create 3 sensor stream objects to describe the sensors we want to connect to, and in doing so we'll also define 3 events to be queued whenever a new packet arrives from the individual sensors. Then we'll create 3 associated publish data action objects to publish the sensor data to our target MQTT server, and lastly we'll create the 3 rules that will tie the new packet events to the publish data action objects. First, we'll create our 3 sensor stream objects. We'll select the sensor type, ANT or Bluetooth, and then we'll pick our sensor from the supported sensors drop-down list. We choose the sensor values we want to enable and specify the name of the event we want to have queued when a new packet arrives from the connected sensor. Lastly, we'll give our sensor stream object a name. Note that when we save our sensor stream object, the corresponding event object we specified is added to the list of event objects in the navigation tree. Now we'll do the same for the other 2 sensors. Next, we'll create the publish data action objects that, when executed, will publish the data from the selected sensor to the specified remote MQTT broker. The publish data action object definition screen has fields for all the most common parameters required to connect to an MQTT broker. To connect to the Eclipse test server we'll use in our example, we'll only need to specify the server address and specify a topic we want to publish our sensor data to. We choose the sensor from the list of sensors we previously defined and select JSON as our packet output format. Though not required for this example, the Extended Options file field, which is covered in Part 2 of this how-to series, allows for much finer control of the connection parameters. It also provides methods for reformatting outgoing JSON packets and for mapping of incoming control packet data to user-defined events to be queued. And again, we'll create similar publish data action objects for each of the sensors we've enabled. Lastly, we'll create the rule objects that will be evaluated every time the triggering events get queued. For each rule, we'll enable a single action object to be executed, which will be the corresponding publish data object for the triggering event. We save the file and push it to the Raspberry Pi running the SoftHub daemon. And then on the Raspberry Pi, we restart the daemon so that it loads the configuration file and executes the rule set we've created. Now using the MQTT.fx utility, we'll connect to the Eclipse test broker and subscribe to the MQTT topic the Raspberry Pi is publishing to. As packets start to arrive, we'll see them in the right side of the screen. To minimize network traffic, packets are published unformatted. So we'll copy a few packets and run them through the JSON lint website to get a clearer idea of what the packets contain. As you can see, all the raw packet data has been decoded and published in JSON format as we'd specified in the configuration file rule set we created. It's worth noting, however, that many commercial MQTT brokers will have their own very specific JSON formatting requirements. In part 2 of our how-to video series, we'll show you how you can transform the generated JSON packets, allowing you to visualize your data on most, if not all, third-party cloud-based dashboards. Thanks for watching, and we hope you'll tune in to watch part 2 of our how-to MQTT video series.